Is Dr. Musk gonna join? Hey!
Yes, Dr. Musk is going to join.
You're 6 minutes late. What were you
know.
doing?
What? I had another meeting that ran long. I was talking to a dean, and deans are the people who control whether I'm in good standing at the college. So I have to talk to them if they want to talk.
Okay.
Did you get in trouble, or you good?
No, I'm good. That because I'm doing what I'm supposed to be doing, which is when the deans need to talk to me, I talk to them.
Okay, just making sure you good. I was a little worried for a hot second there.
No, I'm totally good. All right. So I promised you guys that we would practice today. So I am going to begin by giving you a series of questions. So I'm going to share my screen, and I'll make this worksheet available to everybody when the session is over with. All right. So on your own paper, I would like you guys to answer these questions, and then after enough time, we'll go over them together. All right.
How are you feeling today?
Like pretty much 100%. Other than my arm, my whole arm is still kind of dead a little bit, but the rest of me feels like $1,000,000, which is great. Yeah.
Oh, someone got that vaccine, didn't you?
I got it day before yesterday, and by the time class happened yesterday, I was hurting for certain. Well, actually, like all day. I woke up and my fingertips hurt, and I was shaking and feverish, and I felt gross. But I feel great today. So it was a quick convalescence. I'm sure I'd have been down for more days if I actually caught COVID.
Yeah, yeah.
No, not necessarily.
Yes, but I am certain that I would have been down for more days.
This is not chemistry related. That's
okay,
biological
that's
warfare.
Biology.
Yeah,
we don't need it.
That's not this class. That's a different class. Come on.
I realize that half of people are asymptomatic. My personal feeling, my gut feeling is that I would not have been one of those. I would have been somebody that got it pretty bad. So
yeah,
I'm glad
somebody with asthma, same.
Yeah. Okay, so let me open this. That's not good. That's not good. Why are you asking for a password? I didn't password protect this.
Did someone hack into your computer without you
knowing?
No,
I derived this from a worksheet that was available on the web and made a read-only copy of it and then saved it under my own name, and that should have removed the password protection. Okay. All right. Plan B.
Plan B, make up your own?
Yeah, that's where we're at right now. I can't open this. I'm trying it a couple of different ways. All right. Well, that's terrible. All right. I guess we're going to make this up as we go. That's totally fine. Terrible. Why did I spend half an hour putting this thing together? Okay.
Big mood.
It's frustrating. I hate having to do effort over again that has already been done once.
Big mood.
All right.
Yeah.
So we're making it up as we go along. Here's what I've got so far on my redo.
Oh no, I haven't learned this yet.
You haven't learned chapter 3 at all yet?
I just got into 3.2.
That's totally fine. So this will be great practice for you. All right. So let's do an easy one first.
That's a dull pencil. Okay, next one. Hey, I mean, that's dope. Sarah's getting her vaccine. What is that, a 2 or a 3? That's 3.
That's 3. Remember, if I give you a name, you give me a formula. If I give you a formula, you give me a name. So we've done 2 of each so far. Let's keep going.
Okay, wait. Where are you? Do not have you memorized. Where are you? And the first one is blah blah blah. Oh snap! I looked away and there's more.
There are gonna be.
Okay. Okay, wait. I gotta move you guys down so I can actually read you. Move this to the other monitor, you to this monitor. There we go. Nope, that's... Okay, there we go. Okay, number 6. Chromium? Okay.
And when I say inorganic salts or ionic compounds, same thing. All right. Different books call them different things. I should have been consistent, but inorganic salts is just another word for ionic compounds.
Snap, crackle, and pop. What?
Formatting. All right, let's work through these together. Give you guys some time, because I'd assume that you can't do them as fast as I can write them. But if you can, then that's fantastic. Dr. Musk likes short essay questions. I've never asked this exact question on an exam before, but it's a good question. Maybe I'll throw it in the bank and in a couple of years, I'll use it on a real exam instead of just in practice, but that's a good question right there. So we'll have one little essay question in addition to our other practice for the day. So this is a great little set of questions for us to practice pretty much all of the chapter 3 content. All right. Chapter 2 is our bridge because the electron configurations teach us about the number of valence electrons that different elements have. And then after that, in chapter 3, we learn how those elements use those valence electrons or how they modify them when they make ions to make ionic compounds. So take a bit and try these out. I'm so flippin' irritated that my 20 question worksheet got clipped in a password issue.
Does anyone else hear that really high-pitched noise? Okay, cool.
Let me see if I mute myself if it goes away.
It went away.
Did it come back though?
No.
No.
Sweet. So probably just a Zoom bug. That happens all the time, unfortunately. So let me know when you guys are getting close to done and we can start talking through these. Jules, if you're not all the way through the chapter 3 videos yet, then you don't have to have all of these done. The exam is not going to be until the end of next week, so you have plenty of time left to study. Note that
Cool.
I did drop the putative exam date, so end of next week, we're going to have our first exam over chapters 1 through 3. All right. The time that I'm thinking of having it open is like all day and evening on Friday next week.
30th.
The 30th, that's right.
Okay, I'll make sure that if work tries to call me in, they say get a no.
Remember that by all day, I mean like from 8 in the morning until midnight. So as long as you're not working from 8 in the morning until midnight, all you need is an hour and a half of time to take the test. An hour and a half to take it, and then a half hour to print and scan and turn it in. So if you can budget 2 hours during that day, anytime that day that you're awake, then that will be fine. And if you absolutely can't for some reason, just email me or text me and we'll work it out. It'll be fine.
Cool beans. I think I made up a word.
That happens. So many windows.
And no oxygen. That was a bad joke, I'm sorry.
All right, I'm getting self-conscious. Give me a second to clean my desktop up.
If it makes you feel any better, I feel bad about saying that stupid joke just now.
Don't feel bad. You know, Microsoft was going to do the thing where you could like click windows into place that would take up half of a desktop, and it never works very well. It just doesn't work. It's one of those things that in theory is a great idea.
It usually works for me.
Works for me, but I have to have my screens and my dual monitor set up like very accurately like aligned. Otherwise, it'll be like, oh, you want it on 1 1/3 monitors, and it's like, no, that doesn't exist. Please stop.
Right.
It usually works just fine for me. On my laptop.
My laptop, it does not work at all. Maybe it's something in my settings that I haven't got set right, but. So does somebody want to take a stab at the first question? And remember that when we do questions, we're very focused on the principle behind the question, all right? So tell me as much as you can about like why you're answering the question the way you are, as opposed to just giving me the answer. I know that's a little intimidating, but that's also important for us to vocalize how we understand these concepts, because that's what's going to help us really solidify them the best that we can. Somebody want to volunteer an answer?
I have step one.
What do you have for an answer?
Calcium
For an
fluoride.
answer. Anna says calcium fluoride for the first one.
Yes.
Says calcium fluoride for the first
Yes.
one.
Yes.
I think it's calcium fluoride.
Yes.
So I'm getting some feedback. Okay, maybe it's not. I'm getting some feedback. Nope, I'm getting feedback. Okay, maybe it's not happening. It was Luz. I was Luz. I think you're in your car, right? So I muted you because I think.
Sorry, I unmute myself.
Okay, that's fine. Yeah, we're getting a little bit of feedback there, but Luz and Anna, you are correct. It is calcium fluoride. So tell me the basic idea for what we do when we write our ionic compound names. Like, how did you come up with that from that formula?
You're asking me?
Either one of you both gave me the answer at the same time.
Okay.
Go ahead.
I just use like the name of the first compound. And in the second compound, I took what we learned yesterday and I add the last, like the last letters, the fluoride.
So when you said compound, I think you were meaning elements. So we're talking about the metal element and then the non-metal. Is that what you meant?
The elements.
Okay. Yes. So our general rule is when we write an ionic compound's name, we list the name of the metal first in full, and then we list the first part of the non-metal name, followed by the suffix "ide." So knowing exactly how far to shorten these is a little bit of an interest sometimes, but if you're really close and are just off by a letter or something on an exam, it's all right. If you're close enough, you'll get credit. Somebody want to try number 2? So in this case, we need a formula. And Anna and Luz can't answer because they answered last time.
In the chat,
So I'm not
Jules.
sure. CO3. So cobalt is C and then little o.
C little o, then
Ah,
that
meant-
right there would be
I meant C little o and then big O and then
carbon
3.
oxide 3.
There
So
you go.
that's what you meant, Jules?
Yeah. Yeah.
What you put in there, that's carbon oxide.
Interesting. Well, this would actually be, if it was CO3 with no charges or anything, it would be carbon trioxide, but that doesn't actually exist. So we'll get to that later. Note that carbon and oxygen are both nonmetals, which means that we have to use a different naming system when we name those kinds of compounds. So when nonmetals are with other nonmetals to make a compound, those are covalent compounds, and the rules for naming them are different. So we're going to learn about that at the very beginning of chapter 4. So it's good that you mentioned this, Jules, because what I don't want to see when we're naming any of the ionic compounds is those prefixes saying how many of a kind of atom there are. So if it was CO3 like this, the correct name for that, even though it doesn't really exist, would be carbon trioxide. But that is a covalent compound. We never have to use those prefixes to name ionic compounds. And the reason we don't is because for ionic compounds, we already have a way of knowing how many of each kind of atom. And that's that
Wait,
the
so
charges balance one another.
Is cobalt oxide the covalent, or is the copper trioxide one?
Copper trioxide would be a covalent compound. Cobalt is a metal and oxygen is a nonmetal. So this compound, cobalt-3 oxide, is an ionic compound. So it
that's carbon, not copper.
CO3 would be carbon, not copper, which is Cu, not cobalt, which is C(o). All right.
Okay.
Now we have to evaluate whether this is the correct formula for cobalt-3 oxide. So remember, the rule tells us that this Roman numeral after the metal tells us what the charge of the metal is in the ionic compound. So is this cobalt a cobalt with a charge of +3?
Yes. I think.
As Jules from Pulp Fiction is fond of saying, allow me to retort. So how do we get cobalt's charge in this compound? We get it by knowing what the charge of oxygen is. And oxygen is always the same charge when it is a nonmetal as part of an ionic compound. What is oxygen's charge in an ionic compound?
-2. Or 2 minus.
2 minus, that's right, -2. The reason why is oxygen already has 6 valence electrons and needs to gain 2 electrons to have 8 valence electrons. So if oxygen is a -2, and there are 3 of those oxygens in that compound, what would the total charge of that cobalt be then?
-6.
The cobalt would be -6 to go along with the -6 from the 3 oxygens.
No, +6.
Okay, there we go. Now we have a balanced amount of positive and negative charge. So if I was naming this compound, the correct name for it would be cobalt-6 oxide, because that is cobalt's charge in that compound. So now let's try and write the correct formula for cobalt-3 oxide instead. All right, where we have a balanced amount of positive and negative charge, and the cobalt has a +3 in the compound instead of a +6. What do you guys think?
CO2O3.
Is that Anna?
Sorry, I'm thinking.
Sorry, Anna, you're fine, but you're off limits for the next couple of questions. It sounds like you're gunning for 100% on chapter 3, which is awesome.
Sorry, I'm gonna mute myself.
Don't apologize for being excellent.
No, you're doing good. I'm proud of you.
All right, that's awesome. I just want to make sure that we give everybody a chance to contribute. And if there's some answers that we don't get right away, that's okay. Like, I'm not shaming anybody for getting something wrong. This is an avenue for us to discuss, right? We're trying to get better at this point so that we don't miss these questions next Friday when we have our first test, okay? So
yeah.
You said cobalt-2 and then O3, was that right?
Yeah.
Okay, so let's check our charge balance here. those 3 oxygens would be a -6 for the reasons that we just talked about here, right? 3 of them would be a -6 and 1 cobalt would be a +6. Well, here we have 2 cobalts that have to be a total of +6, which means that each of the individual cobalts is a +3. This is the correct formula for cobalt 3 oxide. Very good. And Anna, you're shut down for a question or two. Got to let somebody else answer. And that's not, you're awesome. All right. So I'm glad that you have internalized this information. That's amazing. I'm very proud of that.
Thank you.
You're welcome.
Me too. I'm proud of you.
Thank you, guys.
All right, anybody want to take a crack at the next one? So this is our first one that has a polyatomic ion in it. So remember, we have a short list of polyatomic ions to know. That list is in the topical videos for chapter 3. Also, Mrs. Lawson has the list on the support course Canvas page as well. All right, so if you need the list of them, it's pretty similar to the one that is on page 92 of chapter 3. Anybody want to take a crack at this one? So that V means that our rhenium has to have a charge of +5 in this compound, +5.
I did it wrong.
So I can say RE. I'm gonna start with the general REM. Okay, so I'm gonna put 2 to the end.
2 to the end.
Yes. Not on the front, just in like inside down. Now I will put 5
Wait a
because
second.
we have 5 of the RE.
We have
Is that-
5 REs in this thing?
No?
No.
I'm asking you, how many REs do you want?
Oh, let me see.
Remember
Oh,
that
One.
tells us
C.
you just want one of them? Okay.
Then the parenthesis mark out right outside to the N.
You want a parentheses?
Yes.
Lose?
I don't. I don't need
No?
a.
I love it when there's division in the class. That makes me so happy. People have to fight it out bitterly.
I mean, I'm trying. Okay.
No, it's totally
I don't
fine.
say I have the
I'm just having fun with
After-
it, Luz. I'm not making fun of you, I promise. So
After-
first of all, just tell me what nitrate is. What is the formula for nitrate?
NO3.
And yeah.
NO3, what is its charge?
Negative.
I have it.
-1.
Luz, are we agreed there? Is it a -1?
Yeah.
Okay. So if nitrate is a -1 and rhenium is a +5,
Mhm.
how many nitrates would we need to balance out the charge from our rhenium?
5.
So there's nitrate. And Olivia is saying we need 5 of those nitrates to go along with each one of the rheniums.
And so we need the 3 and 4 or the RE2. No? So for keep the balance.
Well, let's check our balance right now. All right. So we have 5 of those nitrates, right?
Mm-hmm.
Each one of them is a -1. Are we agreed with that?
Yes, I think so.
Well, I'm asking Luz if she agrees. Luz,
I
do you
agree.
agree?
Yes.
Okay. So we have a total of -5 for our 5 nitrates there. If
Mhm.
that's true, what is the charge of that one rhenium that we have?
5.
+5.
Yes.
What is the charge of rhenium supposed to be according to the problem that I wrote?
5.
5. That looks like a great formula for rhenium 5 nitrate, doesn't it?
Yes.
Because that one rhenium has a +5 charge, which is just enough to balance out with 5 of those -1s from the 5 nitrates.
You
Very
got to
good.
remember the parentheses, otherwise it's wrong.
Yes.
You have to remember the parentheses. Remember, we only use parentheses when there's more than one
Yes, and compost.
of a polyatomic ion in our formula. All right.
Always remember the parentheses. They're important. It's kind of like, let's eat grandma versus let's eat grandma.
Let's eat, comma, grandma. All right, so what about Cu2SO3? Interesting. Oh, there's something popping up in the chat.
So we have
It's
there Cooper, so for oxides, so for
in the comments it says copper 2 sulfite.
Give me just a second.
who is Familia Rodriguez? Oh, I see it. Okay.
Somebody with the last name Rodriguez.
Mm-hmm. But somebody put fam. I imagine a lot of people watching the class.
I think that Catalina is the only Rodriguez we have in the class. Is that
okay?
You? I hope that's Catalina and not somebody else. I think we only have one Rodriguez. Yes. Okay. Awesome. So now let's see if Catalina has the right idea with this compound that she's volunteered the name for. All right. So she says copper 2 sulfite. Now, if that were the case, then the copper in this compound would have to have a +2 charge.
And does it have a +2 charge?
I don't know. Well, let's check. So there are 2 coppers in there and a sulfite. So sulfite, SO3, has a -2 charge. So remember, we're not going to put this in parentheses. I'm going to break it apart into 2 pieces. We have
Could you put the thing back up?
Sharing not up.
Thank you.
I forget to do that sometimes. Apologies.
Thank you.
So SO3 2- is sulfite. If that's true, what is the charge of each one of those coppers in that formula? Olivia, you're not allowed to answer because you contributed to the last one.
Okay.
But that's only because I'm proud of you. I want to make sure that all of us get to the same place where we can ace this next Friday. And I'm feeling good about your chances.
Don't worry, the copper's just wearing a mask. That way we can't see it. It's staying healthy.
It is staying healthy.
So I do feel like it will be 1.
You feel like what would be 1, Luz? The charge on copper?
Yes.
If each one of those coppers had a +1 charge, then the total of the 2 of them would be +2, and that would balance out with the charge of sulfite, which is a -2. So,
but there's 3 of them.
copper 1 sulfite, and I'm sorry I screwed up and had to scratch it out. Copper 1 sulfite is the best answer for this compound's name. So we had to, in this case, we had to figure out what our charge on copper was, and the only way that we could do that was by knowing what the charge of sulfite was. If we know that sulfite, SO3, has a charge of -2, then we can figure out how much charge each one of those coppers have. All right, so when we're naming, we're not putting the total amount of positive charge on the left into this parentheses. We're putting the amount of positive charge on each one of those metals. All right, each one of those coppers is a +1. So that's the number that we're putting in parentheses there. Jules, do you want to give number 5 a go?
What?
I was asking Jules if Jules wanted to contribute a possible guess for number 5. So
KN_3.
K, go ahead.
You need to just feel it, go with the flow.
N, and then 3 under the N.
So let's check our charge balance here. All right. Potassium.
That looks a little whack to me.
Potassium is a group 1 metal. By the way, this compound does exist. All right. It's not what you think. This is not potassium nitride, by the way.
It's not supposed to be KNO.
So this is very careful. All right. This is exactly why I wrote this example in, because spelling is incredibly important sometimes. All right. So just really quick, let's talk about the charge balance if each of these was a regular old nitrogen that was part of an ionic compound. Potassium is a group 1 metal, which means that it has only 1 valence electron, and its charge should be +1 when it forms an ion. Now, if this thing was charge balanced, the only ways that could happen if each of the nitrogens was a regular nitrogen, that this was just a balanced ionic compound, each one of those nitrogens would only have a -1/3 charge. That's a little bit strange. Okay, so what if we reevaluate what nitrogen's charge is supposed to look like in an ionic compound? So nitrogen is a group 5 nonmetal, and we know that nonmetals gain electrons until they have 8 electrons. All right, they gain valence electrons until they have 8. So if nitrogen starts with 5, it's going to gain 1, 2, 3 electrons to form its ion. So we would expect that nitrogen would be a -3 when it forms an ion. So Jules, do you want to take another stab at giving me a formula that balances charges between those two ions?
K3N.
Very good. That is the correct formula for potassium nitride. Now, Luz said something about oxygens. Here is where things get a little crazy. Potassium nitride is not the same thing as potassium nitrite, and it's not the same thing as potassium nitrate. Those are all very, very different compounds. So potassium nitrite, ITE, would have the chemical formula KNO2, because potassium is a +1 and the nitrite polyatomic ion is a -1. We would need one of each of those things to have a balanced ionic compound. Potassium nitrate would be KNO3, because nitrate is NO3 with a -1 charge, and potassium, as part of an ionic compound, has a +1 charge. It turns out that this is a polyatomic ion that we don't teach in this class. That polyatomic ion is called the azide ion.
Azide?
Azide, yep. So the correct name for this would be potassium azide. It exists. Azides tend to be very, very explosive. All right, they're kind of hazardous. Because,
so we're not going to see any of that.
I've used them. I've used them in the lab quite a few times. So the azide ion has some really important chemistry in the world of organic chemistry. We can do cool things using this as a way to form new bonds to carbons. All right. But in this class, no, we won't see it.
Okay.
And we probably won't see it at our houses.
I
There is a
wasn't
place where,
thinking that.
just give me a second and I'll tell you where you probably have seen it before. If you have ever been in an auto accident that was bad enough for your airbag to deploy, there has been some kind of azide salt that has prevented the driver or anybody who ran into an airbag instead of a dashboard from sustaining a serious injury. Azides decompose to release lots and lots of nitrogen gas. So azides like potassium azide are often put into automobile airbags. And the reason why is when you run an electric current through them, they instantaneously turn from the azide into something smaller plus a bunch of N2 gas. So that is a way to inflate the airbag with a lot of gas all at once. And we store it in a very small space because it starts out as a solid. So potassium azide and other small azides like this are solids, but they release a lot of volume of nitrogen gas if we decompose them. So that's a place that you have seen, well, you may not have seen azide salts before. If you've ever seen an airbag deployed, then now you know a use of azide salts. That's an important one, all right?
Could they be in like those canisters, like you know how oxygen is stored?
How oxygen is stored? I'm not sure I understand.
Okay. You go to Party City. They fill the balloon up with helium. Those big green canisters.
Yep.
Would an azide be contained within one of those?
No, so those big green containers are gases that are already compressed at a very high pressure. So when we store an azide like this, it doesn't have to be compressed at all. You could hold potassium azide in your hand, all right? If you were unlucky enough to start the reaction where it decomposed though, it would very quickly explode. And the reason it explodes is because it turns into one of the products of that decomposition reaction is nitrogen, N2 gas.
And you probably wouldn't want to be super close to it when it does that.
No, it really doesn't take very much of an azide salt to make a pretty big bang. Imagine the amount of, all right, let me try and do some back of the envelope calculations here. What do you guys think the volume of a normal car airbag would be? So a car airbag is probably what, about 4 feet across, 4 feet tall, roughly, right? 4 feet by 4 feet by like 2 feet.
Don't you need only like 8 ounces?
It would probably be even less than that. I would guess that it would only take maybe 50 grams, maybe 100 grams of an azide salt, and that would be plenty to absolutely stuff that entire airbag full of N2 gas. So this is a way to store lots of gas by like saving it and then very quickly doing a chemical reaction to release it. All right. So the N2 gas isn't just like held in a pressurized container. It's actually hidden away in this compound and we release it through a chemical reaction. When we talk about decomposition reactions in chapter 5, I'll show you the actual example of that azides decomposing to make nitrogen gas, because it's one that we've all seen when a car airbag deploys. And it happens to be one that happens real fast. Not all decompositions are instantaneous like that. The fact that that one is one of the reasons why it is very useful to us to inflate that airbag before somebody's head can hit the steering wheel. Pretty awesome.
Is there a way to slow down that reaction?
I'm glad I got to mention azide salts just because of this answer, which is amazing. But the N3 minus ion, you don't need to know that one. That's not one of the polyatomic ions we cover in this class. Olivia, what was your question?
Okay, So that just kind of got me thinking about how light bulbs were made, and that's kind of physics, but how they slowed down the explosion rate of, not explosion, but combustion rate of whatever the heck's in the light bulb.
The
Yeah,
filament.
I don't know everything about how light bulbs were made historically at all. I feel kind of guilty that I don't. I know chemists know everything about every chemical reaction that's ever happened.
So light bulbs, they have a vacuum in them to
And then
slow
they have
down
the
the
filament.
reaction.
So the reaction happens because of the presence of oxygen. If there's too much oxygen around, then the filament burns itself out too fast, right?
Yeah, they put in a slight vacuum to decrease to slow down the reaction. It's fun. That's something I learned in high school chemistry.
Now we have LED bulbs in their chemistry.
They had to do it
more sophisticated.
LED bulbs are a quickly blinking light.
So, question. What two things are we putting together to make our compound for number 6? Putting together chromium, I told you that. And what's over here on the right?
Phosphorus and oxygen.
Yeah, phosphorus and 4 oxygens together. What do we call that polyatomic ion? It is on the list of to note.
Phosphate.
Phosphate. So phosphate has a -3 charge. You may not have that memorized now. You should by next Friday when you take your test. Of course, it is open book, open note. So if one of your note pages happen to be the polyatomic ions, I can't stop you. All right. But I'm telling you in real life, you should know this short list of polyatomic ions because you run into them all over the place in the real world. All right. Phosphates are a big part of waste from farms that can make runoff grow too much algae. So phosphates and nitrates are things that we worry about contamination of from farm runoff. All right, so if phosphate has a -3 charge, what is the charge of chromium in that compound?
Three.
Chromium is a +3, but Luz, there are 2 of those phosphates, right?
Oh yeah. It would be 6.
Very good. All right. So now you're getting it. We have to figure out what the charge of that chromium is based on the fact that it's with 2 phosphates that are each a -3. So the best name for that compound would then be chromium 6 phosphate.
VI.
Yep,
Chromium VI.
If you forget a Roman numeral, just write enough dashes to count for that number. If you did 6 ones in your parentheses, whatever, that's fine. All right, it's not a Roman numeral class. I just want you to be familiar with the naming convention.
I can't do anything over 10. I can do up to 9.
You could do more than 10. What's 10? X, right?
Oh, right.
So what's 11?
11's X1.
XI, right? Yeah, so you lied to me. You can do more than 10.
I can do to 12. That's what I can do.
No, and then 13 is the same with 3. And then with 14, you put a B and put 1 in front. And it's the same. You repeat the same.
We had a clock with Roman numerals on it.
So let's try and at least get through the 11 before we're done, and we're already at an hour. So I want to keep us focused.
Okay, I'm sorry.
No, it's totally fine. So aluminum, the metal, has what charge in an ionic compound? There's aluminum right there. It's a member of group 3.
+3?
+3.
No. Okay, yeah.
Don't second guess yourself. Excellent. All right, aluminum is a group 3 metal, so it has a +3 charge when it forms an ion. Carbonate is a polyatomic ion that has the formula CO3 2-. So how are we going to charge balance those in a formula?
Wait, hold up.
Mm,
The carbonates got a charge of -2.
It does. Each one individually has a charge of -2, and each aluminum individually has a charge of +3.
So we put that. We
You know-
put the 2 in front of the AL. Yeah, and then C a parenthesis. Yeah. I'm sorry if I say it wrong.
So
you got it right.
put the carbonate in front.
I say about the parentheses. I don't know how to.
Yeah, you said it right. You got it
Okay.
right.
So
Bueno,
Luz, how many of
muy
these
bueno.
do we want?
So we have 2.
2 aluminums and 2 carbonates?
No, just 2 aluminums and just 1 carbonate.
1 carbonate? So
No,
if
let's see.
carbonate is a -2, that would make each of those aluminums a +1. Is that the
So
right charge for aluminum?
No, we have three carbonates and 2 aluminum. Yes.
If there are 3 carbonates, now we have a total of -6 for our 3 carbonates. And if we have 2 aluminums, now each of our aluminums is a +3. So that is a great looking formula for aluminum carbonate. Good job. All right, so what polyatomic ion is hiding there along with lead?
I made up a word. That is not a word.
So if you don't have all those memorized yet, don't worry. All right, in reality, you can use your notes on the exam anyway. I would like you to have the names and formulas of these memorized just because it will benefit you. OH with a -1 charge is hydroxide polyatomic ion. So if hydroxide has a -1 charge, what would the best name for PbOH2 be then?
Two.
The name for PbOH2 would just be 2? That's
No.
easy. I've been overcomplicating my life, I think.
I mean, it will be. I don't find the PB in the periodic table.
Pb is real far down on the periodic table. Here it is. Right
Okay,
here.
lead. Okay, it
Yeah,
will
lead, just like the lead in fishing sinkers.
be. Okay, it will be lead to hydroxide.
Hydroxide.
That.
Luz, you're great. That's perfect. Yes, that's the name. Lead to hydroxide.
I just
Good job.
remember that when I go to the gym and I ask for the hydro massage bed, they always ask like the hydro, and it's hydro, yes, that.
Yeah, those things are nice. I never ponied up for the membership where I could get the hydro massages though.
I just go for that.
Not for the exercise, just for the hydro massage. I like that.
Where is this?
There are lots of fitness clubs that have those, like hydro massage beds. The Thrive in Oak Harbor has one, but their basic membership doesn't include it, and their basic membership just got twice as expensive as it used to be, so they lost me as a customer at that point.
I just pay the Planet Fitness because the one the Thrive is too expensive, you know, and Planet Fitness is just pay 20 for all the month with the massage beds and everything. So I'm just going for the massage bed. I deserve it.
All right, let's try zinc acetate. So I gave you a hint here. This is the right name for this compound, but it's not a name that's good for beginning chemists. And the reason why is even if you were really smart and memorized your polyatomic ions, like I know you will, and you know that acetate is C2H3O2 with a -1 charge, that's acetate. Zinc is a transition metal, which means that it's going to be hard for us to remember what its charge is supposed to be. All right. So where it is on the periodic table, it's hard for us to be able to tell that it's going to make a +2 ion. All right. I will never make you memorize what the charges are supposed to be for transition metals when they make ionic compounds. Either you'll be able to tell from the formula, or I will tell you like I told you in this case. So in this case, I told you that zinc is a +2 when it forms ionic compounds. So if that's the case, wouldn't we need 2 of those acetates to go along with each zinc in that compound?
Yes.
Yes.
That is the correct formula for zinc 2 acetate, because zinc here has to be a +2 to balance out with those 2 acetates that are each a -1. The last 2 are pretty easy because they're just main group elements. So magnesium is a group 2 metal, which means that it's going to make a +2 ion. Selenide is the truncated name for selenium, which is a group 6 nonmetal. So if selenium is a group 6 nonmetal, it is going to gain 2 electrons when it forms its ion. So we would expect selenide to have a -2 charge. If we have a +2 and a -2, then we're already charge balanced. So the correct formula would have to be MgSe. We just need one of each of those.
I've got so much work ahead of me.
Jules, it's okay. The topical videos are good. Also, we've been working on this for the last couple of recitations. My internet connection has been kind of crap. I was actually kind of surprised that I was able to log in today. I've been trying to upload our last couple of recitations. I've been unable to do that. I'll probably have to wait until late tonight. I think that around this time, there's lots and lots of internet traffic on my block or something. So I'll wait until late tonight and get those uploaded.
No, but for real, talking about something very serious, your videos are so good. It's the first time in all my life that I understand chemistry. And I can tell my mom, she have a degree in chemistry too, and she never could make me understand anything. And either of my teachers in high school. So this week I was like, wow, I feel so intelligent.
Well, I will tell you that there are a lot of really bad chemistry instructors out there. And I don't blame high school instructors that don't do a good job with teaching chemistry, because in reality, to do a good job teaching chemistry, you probably have to have at least like 5 times as many years as you're going to end up teaching. And most high school chemistry teachers don't have a content level master's degree in chemistry. And really, to do a great job teaching it, that's the level of chemistry that you need to know in order to have all the background to like fill in the gaps and do a good job teaching even first year classes. So it's a problem. And honestly, in the United States, we can't pay teachers enough to get content level master's degrees in a discipline. It's not a lucrative enough career. So chemistry is one of those places where we run into a lot of not great teaching at the high school level. And it's a bummer. A lot of times I have to like undo trauma with students that are coming into my class.
For me was a trauma when I was in high school, because the teacher, in the way he was worse and worse, like a
Yeah, Luz, you thought you were bad
was,
at chemistry, right? You thought you were bad at chemistry. No,
I was the worst. I was crying.
I have students all the time that come to my office hours and say, Dr. Musk, I'm just bad at chemistry. Like,
I just went to
no.
study humanities when I graduated from high school, just for don't see chemistry anymore in my life, you know. I'm done with this.
You should be a chemistry major. We
Oh,
need more
man,
rock
that's
star women in the world of chemistry, by the way. It is a male dominated field, which kind of sucks.
I'm only going into the science of the dead. Sorry, not sorry.
It's all right. I can live with it.
Same
So here's our
now.
last one that we'll cover for class today. I'll let you guys worry about number 12. I'll tell you 12A, cobalt. The way we define it, cobalt has just 2 valence electrons because it's a transition metal, all right? All the transition metals, the way we're defining it, have 2 valence electrons. So let's check our balance here. Cesium is a group 1 metal, which means it's going to have a +1 charge. So those 3 cesiums are +3 altogether. That balances out with phosphite, PO3, that has a -3 charge, that polyatomic ion phosphite.
Oh gods, what is my husband doing? Nerd.
Okay, so hopefully this list has given you guys a little bit more practice and talk through some examples. And I will make that worksheet available to, on the course Canvas page along with our recitation tonight so that people can practice and then watch the recitation to get most of the answers. Remember, our first exam is going to be next Friday. All right, so next Friday, the date of next Friday is
30th.
the 30th. And you can take the exam kind of anytime from when you get up in the morning until midnight that night. Budget 2 hours to take the exam and get it turned in. So find a 2-hour block sometime that day. And that'll come out also in announcements. I always make an announcement on Canvas more than a week before the exam day so that students can prepare for it. And if for some reason that day doesn't work for you, just let me know and we'll work something out, okay? It'll be fine. Jennifer, do you have time for review tonight? Is tonight CCB class meeting?
Yeah, I'll have office hours at 6:30.
Amazing. I'm just going to go ahead and hand off to you unless there are any more questions. I know that tonight is our chapter 2 Alex due date. So any last questions on Alex topics from 2? I know that we kind of talked about some of those over the last couple of days. So I think most of you guys are in good shape with chapter 2 at this point.
I have
Already
a
finished
question,
it.
but it's not related at all to Alex or any of that.
Okay,
It
I
is.
can answer. If it's about relationships, I'll probably defer because I'm not good at those at all.
Okay, so hydroxide and hydrogen peroxide, they look fairly similar, correct?
Okay. Do you know what the formula for hydrogen peroxide is?
H2O2.
Yep. Now, I will tell you that this is a little bit weird because there is a polyatomic ion here, and normally polyatomic ions show up in ionic compounds. This is a covalent compound, all right? So it turns out that O2 with a -1 charge, that exists. That is the peroxide ion. So you could have a formula that looked like this, Na2O, that is sodium oxide. If we're practicing sodium oxide, you could also have Na2O2. No, wait, it'll be NaO2. That compound actually exists. That is sodium peroxide. Because remember, peroxide has a, wait a second, O2, I'm getting my charges mixed up here. H2, actually O2 with a -2 charge would be the peroxide ion. Now I'm getting messed up. H2.
Sorry, I didn't mean to confuse you.
It should be O2 with a -2 charge. So why is the -1 sticking in my head?
I didn't
I
mean to
think that
confuse
peroxide
you.
does have a -2 charge. It's just not one of the ions that I ever used for anything. It does have a
That was just stuck in my head.
So don't worry about peroxide. All right. And the reason I say that is because it's not going to show up on an exam anyway. Hydroxide is important. And the reason why it's important is because the amount of hydroxide, OH- in a solution, is one of the ways that we can figure out what the pH of that solution is. So you've heard of the pH scale before, Olivia, right?
Oh yeah,
Okay.
I've used it on my fish for my fish tank.
Right. So you know
I've
that
used it
your
on
pH
lemon
is too
juice.
low. Yeah.
Stomach.
What did you find your pH of lemon juice to be?
Very close to the pH of stomach acid.
Did you like puke and then test the pH of it? Where did you get stomach acid from?
You can find all sorts of things
right?
on the internet. All sorts of things on the internet.
Ask my high school. Ask my high school.
Your high school chemistry teacher brought in stomach acid?
Not my chemistry teacher, but my high school anatomy teacher.
So
where the heck they got it?
They probably just made a solution of hydrochloric acid. So stomach acid is hydrochloric acid with a bunch of other crap in it also. And stomach acid, believe it or not, can actually have a pretty wide pH range. So it can be as low as 1 or a little bit higher than that. So it's got quite a wide range of pHs. Lemon juice is not quite as strong an acid as hydrochloric acid because its acidity is mostly citric acid, which is a weak acid, but it's a pretty strong weak acid. So if you don't know what strong and weak acids are yet, once we get to chapter 9, you'll know the difference between them and also some very basic things about how to figure out what the pH of a solution is. The hydroxide ion is one of the ions that determines what the pH of an aqueous solution is. So anyway, it's really important. It's really important.
Yeah, I needed to do stomach acid for anatomy.
I don't think they were actually having you test somebody's bile juices. I'm just going to go ahead.
I don't know.
Did it look nice and clear and pretty?
No, no, it didn't.
It didn't? All right, I'm not going to ask about that anymore, I guess. So maybe they actually did have you test somebody's stomach acid, which, like, respect, I guess, but
Where
Yeah,
do you get? I know the black market has kidneys, but
I mean, maybe
the
it was
thought
like
of a teacher going to a back alley just to buy stomach acid.
I think it's kind of awesome, actually. Like,
I am still confused.
so Jennifer's about to switch rooms. Jennifer, I'm going to give you the meeting so that you can switch over. All right.
This is how you know that your teachers are sketchy.
I have to switch over to my office hours because I have other classes. So I can't hang out.
I'm gonna assign to you, and then you can switch over now. Or the link to Jennifer's office hours is already in the chat. So when you're ready, just go ahead and pop over there.
Okay.
And I'm taking off, so I guess I'll just assign to Jules instead.
So
there you go.
All right.
All right.
Have a good night, everybody.
Have a
And
nice
remember, tonight, as soon as internet traffic around here dies down, I'll get all of the recitations uploaded for the week so that you guys have everything to look at.
thank you.
Thanks.
Have a good night, everybody, and have a good
Have a
week.
nice night.